All right, students, so this is problem 5 from the problem set PowerPoint that I emailed you all. I wanted to go over this example because I don't think we did a problem involving momentum, and that's what this one is going to involve. So here we have the statement of the problem, and I'm going to draw a diagram that depicts what's going on. So basically we have a car here, and it's moving east. And we also have a van that's moving north. And at some point they collide, and then the resultant mass of car plus van starts moving in, let's say, this direction. And what we want to find is the resultant velocity vector. So I'll call that, let's put that in this color, R. Actually, let's do this. And we also want to find theta, which is the angle right there. So the magnitude of R and the direction of R, the angle of R. So what we're going to do here is we're going to break up the situation into considering the X components and then considering the Y components. That will give us two systems of equations, so we'll be able to solve for the X component of R and the Y component of R, and then combine them using Pythagorean theorem and then, inverse tangent for the angle. So the basic concept here is that we're going to consider the mass of the car times the velocity of the car plus the mass of the van times the velocity of the van. Excuse me. There we go. And basically, we set that equal to, and we're going to do this in both directions. So we set that equal to the combined weight of car plus van, and then that's going to be times the R component. So we'll start with the X direction. Now, fortunately, in the X direction, the van really isn't doing anything. It's just staying constant here. So its velocity is not changing. Thus, we can write that we have the mass of the car times the velocity of the car. Excuse the bad handwriting, please. And then we add the mass of the van times this, which is really 0. So that cancels out, which is nice. And then I'll just write this part out. So we've got mass of car plus, plus the mass of the van. And that's just one big combined thing. And then we're considering the X direction, so I'm just going to call this Rx. So that's the X direction. Now we need to consider the Y direction, which is very similar. It's similar in that, excuse me. The car is not doing anything in the Y direction. It's staying constantly in the same Y position. So we would multiply mass of the car times the velocity of the car in the Y direction, which is 0. So again, that cancels out. We have the mass of the van times the velocity of the van. And then that equals I'm sorry. Combined weight times the y component. And so we set up those systems of equations, and then we can plug in numbers. So first of all, we need to isolate Rx. So I'll just kind of write that out here, but it's kind of worked out in the PowerPoint. So since I write kind of slow, I'm not really going to go through everything. But basically, Rx is going to be, let's do this. It's going to be this divided by this. And similarly, Ry is going to be this divided by this. And so if you do the numbers, you get, and like I say, it's worked out in the PowerPoint, but you would get it's going to be 9.38 meters per second. And then here you got about 12.5 meters per second. And so those are the components. So that's basically the, I guess, the meat of the problem. Just a quick comment, by the way. So here we've got mass. So we've got kilograms up here, we've got meters per second here, and we've got kilograms here. So really the kilograms cancel each other out here, and you're just left with meters per second. So that's how you get those units. Now let's see. The rest is kind of worked out in the last slide, but I'll just kind of put the outline here. So of course we've got the, and this is not drawn to scale. I'm just going to put the number here, 9.38. Then we've got 12.5. So how do we find the hypotenuse? We use Pythagorean theorem. So R is going to equal 12.5 squared plus 9.38 squared, and then you take the square root of that, which is about 15.6. And again, we have meters per second. It's a velocity vector. And so you got that, and then it's up to you which side you want to use for the, well, for the inverse tangent, actually you use the same thing to find the angle. So the angle is going to be, you don't use the hypotenuse at all, is what I mean. So you're going to use inverse tangent of the opposite over the adjacent. So we've got opposite over adjacent. And then when you run those numbers, you get about 53 degrees. And so that's the result. So let's put that there. So your answer would be that the resulting weight or the resulting wreckage moves 15.6 meters per second at an angle of 53 degrees. So there you go. So I hope that helps.